Hello, my name is Arthur Smith. I'm a senior GIS analyst with PDC Energy, and probably like many of you, I'm currently working from home, so presenting this from my home office. We'll see how it goes. My talk is going to be on real-time GIS, lessons learned from a DIY GeoEvent implementation. So to start off, real-time GIS, what is it? So to me, it's not just where things are, but what is happening there now. And where do we get the data to see, what is happening there now? We can get it from the Internet of Things, one of our favorite buzzwords in the tech world right now. There's just an increasing number of objects that are connected to the internet and collecting data. And a lot of this data is spatial. So one of my favorite examples is Google Maps. You can see regular Google Maps. You got a street map. You can see all the various routes you can take to drive around the city. As soon as you check on the live traffic feed, now this is real-time GIS. It's not just the routes you can take, but it's the traffic conditions on those routes right now. Pretty cool stuff. And I think a lot of you know the way they do this. They kind of crowdsource location data from all of our cell phones as we're driving around and aggregate that data into the live traffic conditions. So using our cell phones as the IoT data source. And GIS is an incredibly powerful tool to analyze and visualize this data because a huge volume of observations can be distilled down in GIS and made into something simple and actionable. So a little overview of PDC Energy, the company that I work for. We're an oil and gas exploration and production company, and we operate in Colorado and Texas. We have over 500 employees, with a majority of those going to be out in the field. We're an ESRI GIS shop with web mapping applications used by around 60% of our employees. A combination of Portal for ArcGIS and GeoCortex for our web apps. We're a small GIS team, one administrator and one analyst in IT. I'm the analyst in IT. And then also several data analysts and data owners within other business units. So what is our motivation for implementing real-time GIS at PDC? Really started in 2018. We wanted to modernize our field monitoring room in our Evans, Colorado office up in Weld County, kind of the center of our operations in Colorado. Here's kind of what it looks like. This is not our monitoring room, but what one looks like. You have a lot of screens on the wall, employees at workstations, keeping track of everything that's going on in the field. So we wanted to be able to support this team with some mapping functionality that would be real time. They are interested in what's happening now out in the field and taking actions to maintain safety, optimize production, that kind of thing. So we envisioned a hands-off web map, one that would just sit up on one of these screens that they might interact with, or they might just glance at it, depending on the situation. And here's an example of what one of our facilities looks like. There's valves and meters and tanks, and all of this equipment, or a lot of it, is connected up to a SCADA system. SCADA is supervisory control and data acquisition, and it is a system that allows you to monitor and control devices out in the field over the internet. So 2018, we see the need for real-time GIS. 2019, we spend doing our GeoEvent install and several proof of concept projects. In 2020, this year, we did our first production rollout and working on optimizing that. So on to some of the software that we use for real-time GIS. There's two things that we were looking for back in 2018 when we started looking at our options. And one would be data processing, pulling in the data, ingesting it, and analyzing it, and then also publishing via web services. So we looked at a few different options. First off was ESRI GeoEvent for server, and that is a configurable ArcGIS server extension for processing real-time data, publishing services, doing geofencing analyses, sending notifications via text and email, really a lot of functionality there. We also looked at Safe FME Server, which I'm guessing a lot of you have heard of. It's a widely used spatial ETL, extract, transform, load tool. And it has the ability to process and publish real-time data. You can push to WebSockets using FME, which is pretty cool. We also looked at kind of like the cheapest option would be just, doing data processing via Python, but we would not get any publishing ability with this option, but did take a look at it. So we decided to go with ESRI GeoEvent, and primarily due to these stream service publishing ability that is available within GeoEvent. That was really what drove us to purchase the product. So a little bit on stream services and HTTP versus WS protocols. WS is WebSockets. So looking at traditional WebGIS, that works over HTTP or HTTPS. The user initiates a request. For example, you pan a web mapping application, and so a request is sent to the server, and a response with new data is sent back to the clients, and then that connection is closed. And you have to do this over and over, every time you need new data. So contrasting that with real-time WebGIS, this works a little bit differently. Once the client subscribes to that real-time WebSocket data source and authenticates with the server with his handshake, then you basically open up a kind of bi-directional tunnel where you can just receive or send data without initiating a new request every time. So the client doesn't have to do anything. It can just sit there and receive that data. Really powerful stuff, because you do have an option, with traditional WebGIS, you could just set a timer on your application to okay, pull the new data every minute, but not quite as clean as using WebSockets. And here's a good link where I pulled these diagrams from Geeks for Geeks if you want to check that out. So on to the ESRI ArcGIS GeoEvent for server. What is it? So it is an ArcGIS server add-on, and I have that underlined because you need to have an ArcGIS server already purchased and stood up in order to add GeoEvent onto it. And then GeoEvent is used for processing, analyzing, and publishing the real-time GIS data. Here's an example of what the manager interface looks like within GeoEvent. It's a nice WYSIWYG. What you see is what you get. I can drag my inputs, my processors, my outputs right onto this nice screen here, and I can build out the connections. Here's an example of a real simple GeoEvent service. We're watching a folder for new data, and when we receive new data, we're mapping it from one schema to another, and then pushing all the data out to a stream service to pull into our web mapping application. But if there are any events that pass a certain threshold, in this case, a pressure threshold, then we can send an email for those events. So here's an example of kind of what it looks like to configure these things within GeoEvent Manager. And up in the right-hand screen is a screenshot I pulled from an ESRI presentation, just showing, what processors, which would be in this middle part here, are available out of the box, and then also that you can add from the ESRI gallery. And you can also develop your own. You could do things like, buffer something, intersect, enrich fields, like do a join and, add to your data, that kind of stuff. Here are the inputs that are available in GeoEvent. You can see on the left-hand side out of the box, we have quite a few. And then you've got more that you can add for free from the ESRI gallery, and then even more that you could purchase from some ESRI partners. And then you also have the option to develop your own, which I understand to be quite complex. We did not do any of that for our real-time GeoEvent implementation yet. I think this is one of the most useful input connectors. You can pull an external website, usually an API for JSON or XML or GeoJSON. One thing to note is out of the box, GeoEvent only supports basic HTTPS authentication. So if you need to log in to your API, using something more advanced like token authentication, you're not going to be able to do that out of the box with this tool. Some of these partner ones do include that functionality, but out of the box, you cannot do that. But I'll kind of go over how we worked around that limitation in our implementation. Right-hand side, here's the outputs that are available in GeoEvent. You could do something pretty simple like update a feature in a feature class in a geodatabase. You can send text, email, instant message, alerts. And the one that we were most excited about at PDC is this stream service. So you can send it directly to a stream service from GeoEvent. And like the inputs, you can create your own. And then there's also some that you could, if you need to push to a specific application, there's a few available from the ESRI gallery. And I have a whole presentation from ESRI on GeoEvent, which might be interesting for some of you if you want more information. All right, so on to our first use case at PDC Energy, and that is the gas midstream line pressure monitoring in real time. So high gas midstream line pressures decrease oil and gas production, and that is not good for us because we want to produce, as much as possible, as safely and efficiently as possible. So a little background on what gas midstream is. Within the oil and gas industry, there's kind of three segments. There's upstream, which is, finding oil and natural gas and producing it. That's what we do at PDC Energy. And then once we get the product out of the ground, we're going to get crude oil and natural gas. And, we, deliver the crude oil either via pipeline or truck to a refinery, and we deliver the natural gas to pipelines at the well pad. And you can see it goes through inlet meters into some low pressure pipelines, through compressor stations, into high pressure pipelines, and into gas plants where the natural gas is processed. And then it goes on down the line to, to us to use in our homes, businesses, restaurants, all that good stuff. So what we're interested in visualizing is line pressures at these well pad inlet meters. And you can see here's what those look like. We've got these two sheds here, and you can see we have, 1, 2, 3, 4, 5, 6, 7, 8 outlet pipelines coming out of here. And each one of those comes out of a meter. And this is kind of what those meters look like within their sheds. This device right here, that's what actually takes the pressure and volume measurements. So our monitoring room team wanted a map view to quickly see, hundreds of these pressure measurements and be able to, understand that very quickly. So we wanted to give them a map view that would highlight areas where action is needed. And historically, our employees can view this through a SCADA interface, which is primarily tabular. So you'd be looking at a lot of tables. Like here, we can see pressure values just in a table, but it's not easy to look at, hundreds of these at once. That's where real-time GIS comes in, the ability to quickly, understand this stuff through visualization. And here is what we delivered for them. Here's our application. Very simple. You can see we just have kind of a, stoplight style map. We got our low pressure in green on up to high pressure in red. And then we've got black for any unknown areas where we just haven't got an update from SCADA recently. And, this is all stream services. We have, 5 stream services on this map, and they just update, in real time. And our monitoring room employees, they just keep this up on a screen and they can glance at it to take a quick look. And if they do see any type of high pressure situation, they can, then interact with the map, click on it. They can zoom in and look at, pipeline infrastructure and some other data. But important to remember this map needed to update on its own, not relying on the user panning it, because it's most of the time, unless there's a high pressure situation, just sitting up here, just being looked at. So that's really what drove us towards these stream services. So how did we make that happen? I mean, it seems pretty simple, but there ended up being quite a bit of detail there. You can see kind of a data flow diagram that I'll run through real quick. So the way that it works for us is, we have our sensors out in the field, and those feed data into our SCADA system, which is a product, Weatherford Signet. And then we also have an additional product that sits on top of Signet that exposes the data as an API over the web on our intranet. And from there, we have an ETL server that pulls this API every 15 minutes to get the latest data, and then passes that to our GeoEvent server, which is here. And the GeoEvent server publishes that data as a stream service, and then it's consumed in our web mapping application. We call it Space. That's kind of our internal branding. And that's kind of what our data flow looks like. So an important note is, there's no out-of-the-box connector to go from GeoEvent directly to Signet. That would be sweet if there was. That would have helped us a lot, but it wasn't available. And that's why we had to purchase this additional product to make this data available as JSON from an API, which GeoEvent can pull from. However, we did find it necessary to put this Python script in between GeoEvent and our IoT Gateway API. And this was necessary due to some formatting issues with our JSON out of the API, and then also to deal with clearing old, stale features from our web application, which I will show an example of in a minute. We also had to utilize what's called the store latest functionality on an ESRI stream service, and that is needed to cache the last known value, because like I said, our Python script is only pulling data from the API every 15 minutes. So theoretically, without the caching feature, I pull up the web map, I might not see a new stream update for 14 minutes or something, and that's not going to work for the user. So by using store latest, we cache the last known observation in a database that's managed through ArcGIS server and GeoEvent, and that is kind of broadcast out with the stream service, so you'll always see the last known observation. So on to a few of the limitations that we found with GeoEvent. Your JSON input does need to be clean, a nice clean structure to be pulled into GeoEvent. Showing on the right-hand side, so if we see here, this is what our data looks like coming right out of our IoT Gateway API. You can see this is just one sensor here. This is just one sensor, but I've got 1, 2, 3, 4, 5, 6. I've got 6 JSON packets for that sensor, kind of one for each attribute for the sensor, which you can see here, like our IP address, our system response time in milliseconds, stuff like that. So if I were to pull this directly into GeoEvent, I'd basically get kind of 6 overlapping points. And I actually don't have location with these either. So this just really was not going to work. So we used a Python script to aggregate this based on the ID into one JSON packet and then pass that to GeoEvent. And as I said earlier, you also, if you need to access an API that requires token authentication, we use Python to do this because you can't do that out of the box with GeoEvent. So our Python script also takes care of, as a workaround for this as well. Yeah, our solution was to use Python, and that kind of avoided having to do custom development within GeoEvent. We just didn't, this was a DIY implementation, and we didn't really have the skill set to do that. So we used, a Python workaround to make it happen. So I guess kind of a problem with that is initially we kind of wanted to avoid doing a lot of customizations, avoid custom code, kind of use out of the box GeoEvent functionality. But we're not able to do that due to this limitation or these 2 limitations. A few other limitations that we ran into are stream services, not 100% reliable. We're actually still working through an issue where, with each stream broadcast, we're only getting about 95% of the points to update. You can kind of see what that looks like here. all of these points were updated at 9:50 a.m. in this example. However, this one here, you can see still has the 15-minute old observation. That really shouldn't be happening. And what we had to do as kind of a temporary fix is I put out a client-side refresh on that same 15-minute interval. So my stream services are getting refreshed on the client side to solve this for now. We have been working with ESRI to get this fixed, and we believe once we upgrade to the latest version of GeoEvent, this should solve our problem. We're at 10.5 right now, so just something to be aware of if you're on an older version of ArcGIS server. And then another limitation with stream services is there's no way to clear a stale feature from the server side. You really need to do it on the client side. And there is functionality in the ESRI JavaScript API, which is kind of the back end of our GeoCortex web mapping application to do this. However, it wasn't working the way we expected. And ESRI actually agreed with us that, they're going to change the way that works, but it has not been implemented yet. So we had to do a workaround to clear our stale observations. Basically, if we don't receive an update for one of our sensors, likely because, for example, on our high pressure points, if the pressure dropped and it's no longer in the high pressure stream service, it would just sit on the map forever with the out-of-the-box configuration. So we kind of put some code in our Python script. When it drops back to a different pressure value, we kick the old observation off of the map view, and we just kick them over here to around a 0.0 lat long. So this works, but it's complex and not ideal. But ESRI is working on a fix for this on their client-side API, but something to be aware of. So some pros and cons with GeoEvent for server, and caveat, I've only been working with this for 6 months in production, but this is kind of what we've noticed so far. Some of the pros, the configuration interface is great, WYSIWYG, easy to use, really like it. The event processing, that side of things, super reliable and scalable. Our use case, we're only looking at like less than 1,000 points, every 15 minutes. So not a major, data volume right now, but we are expecting that to grow as we implement more real-time GIS. But I did some tests processing hundreds of thousands of event records. No problem at all, just chugged right through it. That was great. And this one's important for us, GeoEvent and the stream services. It's really a seamless integration with the rest of our ArcGIS server and ESRI stack. So that was very important for us. We can manage the stream services the same way we do our map and feature services. Also a big one is it's backed by ESRI tech support, which they've been great helping us with our implementation, super helpful, great benefit. And GeoEvent is very feature rich. We're only using some of the features right now, but there's a lot of other stuff you can do around geofencing, email notifications, all out of the box, lots of great stuff. Some of the cons kind of already hit on some of these. You won't be able to just throw any JSON input at GeoEvent. It does need to be cleanly formatted. Only supports that basic authentication with the input connectors. That's kind of a big one. You could do a Python workaround or some customization within GeoEvent to solve that, but I'd rather see that out of the box, like the token authentication. It also is kind of expensive. The recommended best practice is to deploy GeoEvent on its own dedicated ArcGIS server. So you'd kind of be expected to buy another ArcGIS server in addition to any that you already have and tack GeoEvent onto there. You don't have to, you could stick it on your existing ArcGIS server, but that's the recommended best practice. And the stream service reliability issues and the complexity with clearing the stale features, definitely kind of a con there that we didn't expect going into it. And it could be overkill for some use cases if you don't need all of these other features. So a few takeaways that I would recommend, for you all, if you're looking to implement real-time GIS at your organization, really understand your business needs and data sources before purchasing software. Identify concrete use cases, look at the data, what format is it, what volume are we expecting, is the data coming from within my organization's network, from the cloud, And how reliable does it need to be? All good questions to answer before purchasing software. And also look at what you can do with what you have right now. See some pilot, do some pilot and proof of concept projects with your existing, GIS technology stack and see what you can do. Because you'd be surprised, you could do a lot with, just standard Esri and Python. And keep in mind that if you do go with GeoEvent for server, most implementations, in my opinion, will require some custom development. Just kind of the reality, it's not as configurable off the shelf as we had hoped. Just something to keep in mind there, but overall a very valuable product. I believe we'll have a few minutes for questions now, which I'm happy to address, but if you want to discuss more in depth, here's my contact information. Very passionate about real-time GIS, so would be happy to talk to anyone on it. Thank you for your time in attending my presentation and enjoy the rest of GIS in the Rockies 2020.